Let's look at another problem, homework problem. And I'm going to not solve the problem entirely for you, instead provide hints. Okay, so let's look at the problem first. The current shown in the figure, this current, so this is supposed to be a current. Y-axis is current in milliamperes, x-axis is time in microamperes. So the current shown in this figure is applied to a 0.25 microfarad capacitance. The initial voltage across the capacitance is 0. Now find the charge on the capacitor at t equals to 15 microseconds. Find the voltage across the capacitor at t equals to 15 microseconds. How would we go about solving this problem? This is something a little different from what we have seen so far, right? We have not seen problems related to charge and capacitance and current relationship. The first thing we want to understand is I, the current, is the rate of flow of charge. Okay, and then you can write Q of t as a function of t0 to t0 or t0 to t1, I of x dx. Okay, or in other words, I of t dt. The idea is if you integrate the current with respect to time, then that will give you your charge. Okay, so in order to find the charge, we want to do the integral. Similarly, in order to find the voltage, think about it, the voltage V of t across the capacitance. Let's go back and see what the formula says. Okay, we may have seen this as a part of the summary. Okay, let me go to wherever the capacitance summary is. Okay, so we can use 1 over c t naught to t I of t dt plus initial voltage. Okay, now let's see. Similarly, 1 over c integral t naught to t I over I of t dt. Okay, so it seems if we have the expression for current, we need the expression for current. If only we have the expression for current, we should be able to plug that into this equation, and then out comes our expected outcomes. Okay, our expected outcomes, which is the charge and voltage. Now, how do you find the expression for current? Well, it's straightforward. In this line segment, it's a line. You can write it as y equals to mx format, right? Because it is pretty much a straight line. That's the equation for where m is the slope. Okay, we can calculate the slope. Similarly, this line segment, okay, the horizontal line segment can be written as x equals to some constant format. Okay, because it is a constant, it's a straight line with slope 0, right? So if only you can express these, straight lines in terms of their equations, okay, then you do have the expressions for current. Once you have the expression for current, you should be able to do the integral. Okay, let's find out what is the current expression in the interval of 0 to 5 microseconds. Okay, look at this. This is 5 microseconds, right? In the interval of 0 to 5 microseconds, that is this guy, it's a straight line with slope 80k. Okay, how do I know the slope is 80k? Because there is this point 0, 0, and this point for 400 milli in 5 microseconds. Okay, 5 microseconds is the time, 400 milli is the current. Okay, now you can find the slope of this straight line that goes through the 2.00 and this point 5 microseconds and 400 milliseconds. That comes out to be 80k. Okay, so you can write it as 400 into 10 to the negative 3 amperes by 5 into 10 to the negative 6 amperes. If you find the slope um, y2 minus y1 by x2 minus x1. So in the time period of 0 to 5 microseconds, I is multiplied by t, of course. I is really 80,000 t amperes per second between 0 and 5 microseconds. How about the second interval? Okay, the second interval where the current is straight line right here. Okay, in this region, the current is a constant 400 milliamperes, right? 400 milliamperes. It is not dependent on time. Even when time is changing, the current is constant. So we can write this is I1, I2 is 400 milliamperes between 5 microseconds, between 5 microseconds and 20 microseconds. Okay, so you have an expression for current here, you have an expression for current there. So what you can do is and you don't worry about the rest of the curve. That's not your problem because you are only interested in calculating the current, the voltage and charge up to 15 seconds. Okay, so if you solve the problem up until what they ask, don't worry about solving more than necessary. Okay, that's all right. That's all a good idea. Now, let us see. So this is 15 microseconds. Let me annotate this. 15 microseconds. Okay, very good. So in order to find the charge, that is what we are after, Q. In order to find the charge, you take both the currents I1 and integrate it from 0 to 5 microseconds because that's the current equation in that 0 to 5 microsecond time period. Then there is this 5 microseconds to 15 microseconds for the current in I2. Okay, so I1 and then um, dt plus integral 5 microseconds, 15 microseconds, I2 dt. Okay, and then 5 microseconds. We can write it as 0 to 5 micro and then 80,000 t dt plus 5 microsecond to 15 microsecond. I2 is what? 400 milliamperes dt. Okay, or dx. The idea is if you plug in these numbers, you should be able to calculate the value of charge Q at 15 microseconds. Okay, I have shown you what to do. You just have to plug those numbers in. Now, when you're calculating the voltage, that's the part B, voltage is nothing but 1 over C integral 0 to 5 microseconds I1 dx plus 1 over C integral 5 microseconds to 15 microseconds I2 dx. Okay, so it's pretty much the same. Think about this. What you have here and here is the same. Okay, all of this is the same. Now, similarly, it's the same case here. All of this is still the same. The only thing that's different is now you have an additional 1 over C term. Okay, um, you can verify that once you do Q equals to VC, okay, Q equals to VC, you should see that V equals to Q over C, and not surprisingly, you have a 1 over C term plus the exact same thing that represents your Q. Okay, so let's say you got a value of, I don't know, I'm just picking randomly, whatever it is, 500 microcoulombs or 50, 100 microcoulombs, whatever number you get here, and you divide that by the value of the capacitance, which is given to be 0.25 microfarad, 0.25 microfarad, that division number should give you your voltage. Okay, so this is how you would go about solving the problem. The first thing you do is to write the straight line equations for the current. Then you integrate it to get the charge. And then you integrate the same thing with a 1 over C term to get the voltage. Okay, so that is how you would go about doing a problem similar to this on the homework.